All right, this is going to be a review using an old AP question from 1999, and it's a probability question. In looking through old tests, you can see a lot of years one question is dedicated to probability. It might be binomial and geometric, or it might be a straightforward probability, but we're going to kind of lump all those together in this review unit and focus on probabilities of different types. Okay, so here's one. We're talking about playing a game with two kind of funky dice. One of them has 4 9s and 2 zeros. The other one has 4 11s and 2 3s. Two people roll them. Whoever gets the higher number wins, pretty much. So if player A gets a 9, player B gets a 3, then A wins. If A gets a 0, then he definitely loses. If B gets an 11, he definitely wins, and so on and so forth. All right, so what we need here is we're trying to figure out the probability that A and B win. The first question is, you're the first player and you want to win, which one would you choose? So basically, which one is better, A or B? And if there are a lot of different possibilities that might happen, the way that you can organize this situation is with a sample space. A sample space is a list of all possible outcomes in an experiment. And in this case, the experiment is rolling both of the dice. So we have 4 9s and 2 zeros on one of them. And then we have 4 3s and 2 11s on the other. And we're going to see which one, this one up here was A, this one was B. Which one of them is going to win in more outcomes? Now, there are 36 physical ways that these two dice can fall, 6 choices from each. And what's going to happen, let's see, we're going to have an A win if it's higher anytime we get a 9 on die A and a 3 on die B. Those are all going to be A winning. So these 16 outcomes make A a winner. So any of those intersections of 9 and 3, that makes A win. If die A is a 0, then no matter what, it's losing. So these, let's see, that's a 2 by 6. These 12 outcomes over here mean B's the winner. And then also, B is going to win no matter what if the 11 shows up. So that's 8 more. So let's see, there are 12 here. There are 8 here for 20. And then these 16 make A the winner. So that's just a quick sample space, sort of. I didn't make a whole lot out of it, but I organized all the possibilities. Sometimes A wins, sometimes B wins, but if I want to win this game on a regular basis, I'm going to choose die B, justify your answer. So my answer, and you need to write and explain the best you can in situations like this. So I would say I would choose die B. The probability that B beats A is, what was that? That was 20 out of 36. And if I divide both of those by 4, I get 5 out of 9. And then my sample space is the rest of the justification. And I could elaborate on that a little bit more if it were the test day, but as long as you get the basics now, you can focus on your elaborating later. All right, so question A, which one do I want? I want die B. All right, question B. Suppose the player using die A receives 45 tokens each time he or she wins. How many tokens must the player using die B receive each time he or she wins in order for this to be a fair game? Explain how you found your answer. Okay, so B is better. So B is going to win more often, so B shouldn't win as many tokens as A. So this is basically, you know, an expected value or a value of the game type thing. Question B. If I want this thing to be fair, then I want the expected number of tokens that A wins to equal the expected number of tokens that B wins. So I need this to be a balanced equation. So I would expect A to win 4 out of every 9, which is 16/36 simplified. So 4 out of every 9 times I expect A to win, and then it told me that A wins 45 tokens every time A wins. Player A, 45 tokens. So I want to balance that out with 5/9 times X. And X is my unknown. It's my number of tokens that B needs to win to make this game fair. All right, so to solve this equation, basically I'm going to multiply both sides of it by 9/5 to cancel out with the 5/9. And I get 4 times 45 over 5, which is 4/5 of 45, which is, make sure here, that's 0.845, which is 36. I should know that. So, long story short, if you want to make this game fair, a game where B should win more often, then B should be eligible for 36 tokens, whereas A should win 45 tokens. And that's it. There's not much to this one. The probability questions, if you're ready for them, they can be answered quickly, and that'll save you some time to spend on your other type questions. You know, if you're doing a hypothesis test or confidence interval, you're going to have to explain a lot more, and they're going to take some time. So ones like this, get those probabilities, move along quickly. All right, so we'll just call that a video. Keep reviewing this probability. Going to ace that AP exam. See ya. Young out.